So let's take a look at let's look at 93D. And this is an integral involving the product of powers of tangent and secant. In addition, we have this pi x. So what's going on here? Tangent cubed pi x, secant to the fourth pi x. What's that mean? Remember what this means. This means tangent of the quantity pi x, and then all cubed. So notice you start with pi x, plug that into the tangent function, and then you cube it after taking the tangent. Sorry, I need a little water. Then over here, similarly, you have secant of pi x, and then raise that to the fourth power. There's two ways you can go about doing this. I'm going to, first of all, I'm going to clean up. I'm going to show you method one here. I'm going to clean up first with a little substitution. You don't have to do this, but I'll explain later. I'm going to let W be pi x. So the derivative of W with respect to x is just pi, right? dW dx is just pi, because pi is a constant, right? It's like the derivative of 3x is 3. So the derivative of pi x is pi. So dW over dx is pi. I get dW is pi dx. And then multiplying by 1 over pi, or dividing by pi on both sides, I get 1 over pi dW equals dx. So I'm just going to replace the dx with 1 over pi, which is a constant multiple, pull that out, dW. And then I've got tangent of pi x, or tangent of W, and secant W. So again, going back to our tangent of W to the third power is tangent cubed W, and then this would be secant to the fourth W. But my first method, I'm actually going to, because it's an even power of secants, I'm going to peel off a secant squared factor. So I'm going to write secant squared times secant squared is secant to the fourth. I'm going to peel off a secant squared factor, and this will be for my du. Okay, so I've got another substitution that I'm going to do. So I got tangent cubed W, tangent, and then the secant squared W. Remember the Pythagorean identity for tangent secant says tangent squared y plus 1 is secant squared y. So in this case, secant squared W then would be tangent squared W plus 1. Okay, and so that's what I'm going to do. I'm going to let U be tangent W. So my du is the secant squared W dW. And I get, replacing tangent W rather with U, I get, don't forget your 1 over pi, I get U cubed, secant squared W, right, it's tangent squared W plus 1, so U is tangent squared W, U squared plus 1 quantity, right, and then the secant squared W dW is the du. Okay, now you could also get here in one step. I did 2 steps, right, with 2 substitutions. You could do all this with the substitution letting U simply be tangent of pi x, and realize when you take the derivative du by the chain rule, the derivative is secant squared pi x times the derivative of pi x, which is pi. So you get pi secant squared pi x. And so you're still going to have to do what? Multiply both sides by 1 over pi. Okay. If you peel off from the very beginning, you can peel off a secant squared pi x factor, secant squared pi x dx. That would be part of your du. Okay, but you'd still get that 1 over pi. If you do it this way, you can do, these 2 substitutions that I've done essentially in one step. Either way, you're going to get to this situation here. What do we do here now? Remember, I can't just integrate this and multiply. No, you can't do that. There is no such thing as a product rule like that for integration, just like there's no product rule like that for derivatives, right? So I have to simplify by distributing U cubed. U cubed times U squared is U to the 5th. Make sure you're adding the exponents and not multiplying them, right? 3 plus 2 is 5. U cubed times 1 is U cubed. Now it's just power rule, right? Antiderivative U to the 5th, 1/6 U to the 6th. Antiderivative U cubed, 1/4 U to the 4th. Multiply through by the 1 over pi. Remember what U was? It was tangent of W, if you remember, right? So I replace that with tangent of W. I get tangent to the 6th of W plus 1/4 tangent to the 4th of W. But don't forget what W was. W was pi x. And so if I do that, and if I distribute this 1 over pi, I get 1 over 6 pi tangent of pi x to the 6th power plus, multiply by 1 over pi, 1 over 4 pi tangent to the 4th of pi x plus a constant. And that's the answer. Okay, so that's method one, but it turns out that you could also, if you wanted to, because there is a odd tangent power, you can peel off a secant tangent factor for the du and use a secant, and that's the second method. So in other words, going back to the same integral here, tangent cubed secant to the fourth I've got down here, and so I can peel off a tangent and a secant. So I take away one tangent, that leaves me 2. All right, take away one secant, that leaves me 3. I've got secant w, tangent w, dw for the du again. So this will be my du. And notice the tangent squared I convert to secants. Remember, tangent squared, w plus 1, right? Tangent squared plus 1 is secant squared. So tangent squared is secant squared minus 1. So be careful about that, secant squared w minus 1. Make sure on the test that you remember you will have the trig help sheet, which has all those identities on it. So if I let u be secant w, du is secant w tangent w. So there's my du. This becomes 1 over pi u squared minus 1, u cubed. Distribute the u cubed, right? Very similar to what we had before. Take the antiderivative of u to the 5th and u cubed. And then remember, u was secant w in this case. Distribute the 1 over pi. Remember, w was pi over x. And you get this result. So it turns out that these two results that we get, this one here, and this is what I have in the back, I think, as the answer, but this is equally correct. Now they look different, but they are actually going to be the same functions. Although remember, in general, they could differ by a constant. So antiderivatives can differ by a constant. But in this case, these two functions are identical in this case, it turns out. But here's the problem, with trying to do some of these integrals involving trig functions or logarithms. There's properties, there's identities, there's things we can transform, different ways of doing it. There's not necessarily only one way. And you just have to, work hard at, experiencing the different ways of doing this. And that's why I wanted to show you these two methods. You do not have to show two methods on the test or for homework or anything, right? Just take the method that works. Okay. So I hope this helps with number 93D.